This is a Carboline production.
During this episode, we discuss CUI, its true meaning, and the various factors that influence corrosion with our good friend Michael Pardo of S&B Engineers and Constructors. We also touch on the value that mentorships bring to the coatings industry. All of that and more coming up next on The Red Bucket. Here we are with another edition of The Red Bucket. Paul, how's it going?
It's going well, Jack. I think we're finally hitting a stride with this thing.
Yeah, here we are again in Houston, and today we are going to be joined by a special friend. We're not going to bring him up yet, but we have a great tradition that we have with this guy.
We sure do. We've been friends for a few years, and we see each other always when we come to these conferences or when we travel, especially if we come to Houston for anything.
Yeah, and so one of the things we do is anytime that the three of us are together, we go to a sporting event. Yeah. We've been to NBA games. We've been to MLB games, hockey games, NFL games. Yep. And it's a great way to spend your time when you're in a different city, and even better when you're with good friends.
And all of us are sports fans, so it's an easy thing to just find some professional level event to go to and have a good time.
We're lucky enough to be joined by Michael Pardo today of S&B Engineers, one of our good friends. Hey, Michael, welcome to the show.
Thanks, Jack. Thanks, Paul. Appreciate being here. Thanks for inviting me on today. I'm looking forward to this fun, riveting conversation we're about to have.
It will be riveting.
Yeah, and I can't believe of all these years of us doing a podcast and being friends with Michael that we've never had him on. I guess we finally hit that level of acceptance that now
he meets the bar,
or we meet his bar.
Or maybe I'm just around too much and you think I've been on the show.
Yeah, maybe.
So let's start there. Michael, tell us a little bit about your background, who you are, what you've done in the industry.
Yeah, so I actually started out back in Birmingham, Alabama, actually working for a special inspections company. They did geotech engineering and stuff like that, and we did a lot of welding and welding inspections and things and concrete inspections, and started out there and then moved on to Bechtel Corporation for a few years. Worked there for two of the greatest minds in the industry, Ben Foltz and Patrick Naw, and that's where I really got my start in the coating side of things. And I had two wonderful mentors and teachers in that regard. And then Steve Young was my insulation and fireproofing mentor, and three great mentors that I was very fortunate to have. And not a lot of people in the industry get that opportunity to not, a lot of people maybe have one mentor or, they have somebody outside their company that they can call. Right. But I was so fortunate that I had three. Right. I had, just like I said, Ben Foltz, Patrick Naw, and Steve Young, and they really helped propel my career where I am today. And they got me involved with SSPC at the time, a little bit with NACE. Then they joined, so now I'm heavily involved with AMP. Ben and Pat had me involved with the Houston Coating Society, which I'm the secretary of the Houston Coating Society this year and the trade show chairman.
I do have to do a little bit of a shameless plug here because mentorship is so important, right? And it's something that I do agree with you. You're extremely lucky to have three different mentors and in-house. But if you find yourself in the coatings industry and you don't have a mentor, and especially if you're a young engineer or a young spec writer, or even a young contractor, if you want to learn more about the industry, we have a program. It's called Carbo Next. And what we're going to do is not only is it an education platform, but we'll pair you up with one of our subject matter experts who can be a mentor for you. So that is a great program that we have at Carboline. You can find that at carboline.com. It's enough for the shameless plug.
Well, that's awesome. That's great for the industry, Jack. I didn't know you guys were doing that, and that is a fantastic idea because we're losing so many people in the industry right now, and we're not bridging the gap. It's huge right now in our industry. We have we don't have a lot of people coming up right now that are interested in doing coatings, insulation, and fireproofing. And a lot of the guys that are doing it right now, they're ready to retire, and there's nobody to help. And I know when I sit in some of these process industry practice meetings and some of these AMP and some of these meetings, I'm the youngest in the room, and the age gap between me and the next youngest could be anywhere from 15, 20 years. So we have to figure out a way to help bridge that gap and entice engineers into our industry and show them that it's a very lucrative career. Like it's not just something that it's a stepping stone at all. It's a career, and I'm making a career out of it. And this has been, I love what I do. So this has been a very, very exciting career path and very educational career path with all the certifications and everything that I can go get and things I can learn to not just help myself, but also help my company that I work for.
Sure.
So, it looks good to owners too. They like to see that type of thing. So.
Yeah. And you don't want to say it's easy, but it is as streamlined and focused or as varied and different as you want it to be.
Yeah.
You can get into a path and lock yourself into a track and just stay focused on that, or just keep branching off. There are so many options.
And that's a good point that you bring up too, is that, as an engineer, I want to ask you, why'd you stay? Because so many engineers go to school. They don't go to school for paint.
Right.
But they get paint first. They join the engineering firm. You're going to be the paint guy.
Yep.
But they run back to mechanical as fast as they can, or they run back to whatever their specialty as fast as they can. Why'd you stay, Mike?
So I say because I saw a need. I saw a need for younger engineers to fulfill these roles, and right place, right time to a degree too. Like I said, when I was working for Bechtel, I came into a great opportunity and had some great mentors that, even though they were very tough on you, very tough on me, and it made me go out there to learn and to kind of show them that I wanted to learn this stuff. Kind of with my career where I'm at, I left Bechtel, resigned out of there, and took a job with Aspen Aerogel. I wanted to go get some experience with a manufacturer, see what they deal with on a day-to-day basis.
We deal with you.
Yeah, you got to deal with somebody like me. I know. I have got a whole new sense of respect and a whole new sense of. I don't turn down phone calls. I'm not that type of guy. I want to learn. I want to know innovative new things that are happening. And so when I took that role, it taught me that I realized there's a lot of people that just ignore you. They ignore your phone calls. They ignore responding back to you. But it was a very humbling experience because, people I knew from the industry that once I got to Aspen, I'd call them and not get an email back or maybe a phone call back. And eventually I'd get in contact with them, but it was humbling because it was like, oh, he works for a manufacturer now. I don't have to get back to him. But when I was working for Bechtel, it was, they get back to me pretty quick because, he works for an EPC. He needs to, we need to help him out. But there was an opportunity that came up when I was with Aspen. I had no plans on leaving Aspen. They were a great company. They treated me very well. But there was an opportunity. S&B approached me, and there was just an opportunity to get back into the EPC ballgame. And because I saw that's kind of where my heart is. I enjoy the projects. I enjoy developing systems. Working on things that most people don't get to work on in their career. Working on things from hydrogen to LNG to, petrochemical plants and things along that line. Like not many people can say, hey, I built that, or not built it, but hey, I was a part of building that. I wrote the spec that went into that project. And you see so much where some companies they're failing in that side, and they're having issues out there in the industry because they're picking things from just Google searches, and they're not using their subject matter experts to the way they should be using them. So.
Well, I think you brought up SMB engineers and constructors. That's who you work for now. Let's talk a little bit about what you guys do there.
Yeah, so we're a mid-scale engineering procurement construction company, and we're on the move. They definitely have made some strategic hires, and It's a great company, and they're propelling upwards.
Yeah. So we know that over time you've kind of developed yourself into a little bit of projects and types of products that are of interest. You know, a lot of insulative type products, whether it be through your manufacturing stint that you did, or, you know, when you were with Bechtel, a lot of the stuff you worked with, insulation, fireproofing, coatings and corrosion, under insulation kind of things.
Yeah.
Why don't you tell us a little bit about how you got there, what you see there? I guess we start with, you know, the term that a lot of people throw around is CUI.
Oh yeah. So corrosion under insulation, man, it's a hot topic. It's, you know, it's also very contentious in the industry. You know, everybody has their opinion. They have their opinions on what temperature you should be worried about in CUI range. You know, just thinking off the top of my head, I know AMP talks about at or below like 175 degrees Fahrenheit. Intertech mentions minus 10 Fahrenheit to 250 Fahrenheit. I've seen other places that are, you know, 25 degrees Fahrenheit to 350 Fahrenheit. Me personally, I tend to look at that minus 10 to 350 because you can see, especially in like cyclic areas, you can see these, you can see issues in those areas. So you have to encompass a broader range. So, but everybody, that's what I'm saying. It's such a contentious issue that nobody can say this is the temperature range you have to be in.
Well, I think you hit it on the head. The cyclic.
Yeah.
Like when something's operating at 400 degrees, it's kind of hard to have that corrosion cell happening because most of the moisture that would create that corrosion cell is going to evaporate off.
It moves away.
It moves away. But if that thing that's operating at 400 degrees drops down to ambient temperatures or something like that, now you have a situation where
you have introduced electrolytes.
Yeah.
You have introduced moisture. You've introduced water into your system at that point, because that during that cyclic cool down, that's what happens. So
to give you guys a clue of just how debated this subject matter is, there is an ISO standard. There is now a standard test method through NACE. I sat on a conference call this morning for yet another test method. I know of at least 2 manufacturers that have different test methods. So just off the top of my head, I'm coming up with 5 different test methods that are viable, that all predict something related to CUI, but nobody can agree on one.
Not only can they not agree on one test method, there's not always agreement on what you do to prevent it, what you do to predict it. That's just to test it. And, you know, one of the things that always comes back, even all the way down to the term CUI.
Right. That gets debated.
When somebody says CUI, do they mean, now we know under insulation, that's the UI.
Right. Never debated.
But are we talking about corrosion, what is actually happening to the substrate, or are we talking about the coatings, which are trying to prevent that corrosion from happening to the substrate? Now, fundamentally, the breakdown of a coating is also corrosion.
Yeah.
But most people don't think of it that way, but it is a corrosion process. So theoretically, maybe corrosion is the right word, but most of the time, these test methods that we do are to talk about what coatings can we use under insulation, and then the mechanism is corrosion that they're trying to prevent or evaluate. So even from as simple as, what do we call it? There's debate.
yeah, I feel like over the last few years, we've had so many presentations through AMP, through Bring on the Heat, through, you know, some of the conferences. I think we're slowly gravitating towards everybody is realizing that it's corrosion. I think we're getting to that point now, but you're right. I still sometimes hear, are you talking about coatings or corrosion? And I'm like, it's corrosion under insulation.
Yeah.
We deal with coatings because we put the coatings under the insulation for corrosion, but I think it's becoming widely accepted that it's corrosion under insulation. So
okay, now let's go one step deeper. Insulation, although we all agree that that's what the eye is for, there's a lot of different things that are used or that have an insulative effect on a coating system that causes corrosion. So why don't you tell us a little bit about your perspective, because there's a lot of different things that are in this field, and I know you've dealt with most of them.
Yeah, so from an insulation standpoint, people have to, a lot of people have to understand that not all insulations are created equal. They are insulations that are made for different processes, different environments. Mm-hmm. Each insulation has its own unique use.
Okay.
And not all of them are going to work for CUI. A lot of your manufacturers think that their insulation works fine with CUI, but in my design, looking at things, some of the ones that I tend to design around are with the air gels, the expanded perlites, and the foam glass, because they don't absorb water. That's the main thing. You don't want absorption. You don't want it to sit. You don't want water sitting on your pipe. You want it to wick away. You want it to be able to outgas out, or just shut off. And so, with these insulations, you got to think of it like a sponge. Mm-hmm. Mm-hmm. When you're washing dishes and you got that little green and yellow sponge.
Yep.
Would you put that sponge soaking wet on a piece of pipe outside?
I mean, if I wanted to see corrosion, I would.
Right.
Yeah. So you have a lot of installations that's what they do. They just soak up water. And you have a lot of I shouldn't say EPCs, you have a lot of design companies out there that they're looking at the cheapest method, the cheapest possible route to go.
Sure.
And maybe they don't understand that a mineral wool type material is like a sponge. But they use it because it's like, I can get that for $1.30 a square foot compared to foam glass at like $7 a square foot. Yeah. Money adds up. I understand, but we have to be cognizant of our design and the whole design. And it's not just insulation. The design is also what coating, because you need that barrier. You need that second line of defense in case your insulation breaks down, in case there's damage. How many times have y'all been out to a site and you've walked through a rack looking for a pipe that was coated, but you've walked through that rack and you see insulation or aluminum jacketing that's all damaged, turn up.
Oh, yeah.
Never. It's always perfect.
It's always perfect, pristine condition.
Perfectly sealed.
Yeah. So that's the first thing I think about when I'm designing is, okay, this is going in a pipe rack. They're going to be walking on it. This has got to have a coating on it. And that's my second line of defense to prevent any type of corrosion. I might not have answered your question you just asked. I might have just gone a whole convoluted route around.
But you did bring up, you brought up a couple, and one of them, you'd brought up like a mineral wool kind of insulation and how it holds moisture. My wife and I were recent empty nesters. Our youngest has just gone off to college. And one of the hobbies that we've picked up, especially my wife, was hydroponic plant growth.
Yeah.
And we're having a great time with it. But one of the things that they recommend is mineral wool to do your root starting and to use it in the hydroponics. And when my wife said what she wanted, I was like, you can go here. Here's what you need. Here's out. And she looks at me, she goes, why do you know anything about this? I was like, well, we deal with it all the time. I go, it's used for insulation. She goes, but it holds water. Why do you want that on paint? Now, the other thing that you brought up that made me think of when you said like a sponge, it's not always just something that is designed specifically for insulation that is going to act like insulation and cause these possible corrosion cells, because we have a lot of fireproofing materials that are put on at the same thicknesses as insulation, and a lot of them are cementitious. And we've talked about it before. Cementitious products, cement is like a sponge.
Yeah.
Mm-hmm. Water freely goes through there and it absorbs it, it holds onto it, and it puts it right up against those substrates. And so it is another thing that you have to keep in mind is what primers are you using under cementitious any fireproofing that may allow for that, because you get an insulative factor with it.
Yeah.
Is that something that you've had to work with or work around? And
Oh yeah. Yeah, definitely. So anytime I design a fireproofing system or an insulation system, the first thing I think about is what primer am I going to use? What temperatures is this going to see? Where is it going? Is it going to be indoors? Is it in a controlled environment? Because I dealt with a project that was E119 based. It wasn't jet or pool. It was building construction materials inside, controlled environment. There was a lot of thought that went into that versus an outdoor plant like your LNG facilities are outside. So you have to think, where's it going? What's, what type of contaminants could it see? What type of temperatures is it going to see? Is it going to see the elements? Is it going to see sun degradation? So you got to think about all those factors that go into designing these systems. But yeah, the first thing that I always think about is, what is my primer going to be? Yep. What is my base coat? Because that sets the stage for what's later.
And, one of the things, it was funny the first time I saw it, and it all dawned on me, was looking at a pipe that I knew it was a steam pipe. It was hot, it was insulated, and it was covered in snow. And you look at it, and first you think about it, and somebody says, well, it's a steam pipe, so it's hot, so you don't have to worry about snow. But if the insulation's doing its job, now you have snow sitting on the insulation. You will have water wick into it, especially if you go through cyclic conditions on that.
It doesn't matter how good your craftsmen are, how good your insulation system design is. Water is an interesting phenomena. It finds its way.
Water will find a way
everywhere. I had a not a hole, but I had a leak in my roof. Well, I thought it was coming from one area, so I went up there and messed around. That leak was from the other side of my roof that somehow found its way to this side, to my front side of my house. That water traveled. The only reason I knew is because I sat up there during a storm one night with a flashlight. Man. Because I was so peeved that I couldn't find where this water was coming from. I sat up there. This is an engineer right here.
That was what went through my brain immediately. I was like, engineer.
Sat up there with a flashlight. I turned the lights off because I have lights in the attic, but I turned the lights off. I had a flashlight, and I listened for thumps, water drippings.
So we're always aiming to educate, and so on that line, we talked about using coatings for protection when it comes to CUI. So let's talk a little bit about the types of coatings that you use to protect steel, why you'd use one over another, and those kind of things.
I think the main thing when I'm looking at systems for pipe, you have an all-encompassing epoxy Novolac. It's really that's the system route I like to go with most of my under insulation. It can be used on carbon steel and stainless, so I can go both routes. I'm not having to worry. Oh, can I use this system on the stainless steel? Well, yeah, you can use an epoxy Novolac. So I tend to gravitate towards the Novolacs, the phenolics. Those are always great products that we've not seen issues with underneath insulation. I'm sure there's somebody that's going to be listening to this or listening on that's going to call y'all and say, oh, I've had so many issues with epoxy Novolacs. Teach their own.
There's always going to be an exception.
Always going to be an exception, but you got to ask those questions. You got to say, what environment was it in? What product did you use? Did they put it on correctly? They put 2 coats. They put 3 coats. What was the millage, the thickness on it? Those are all things you got to take into account. And when you're thinking about coatings and can it be shop applied or field applied? Those are huge thoughts that run through your head or run through my head when I'm designing these systems and designing these for projects. And then the big thing is keeping the owner's best interest when I'm designing these systems. Like, we might not, maybe our design life or our design or warranty's 5 years, but I don't want a coating just to last 5 years. Right. So I'm looking at durability, looking at longevity for these coatings, and looking out for our client owner's best interests and giving them a product that, hey, we don't have maintenance in the budget for the first 5 years. We really need this to last, things like that. So, but your epoxy Novolacs and your phenolics, and those are really the main products I'm using right now underneath the insulation.
And we've kind of danced kind of around this concept this whole time, right? We've talked about longevity, years, and things like that. And you said referenced, maybe this one solution is more expensive and we're looking at dollars and cents up front, but we really should be looking at how much it costs us through the life of the asset.
Exactly.
So if the insulation is more expensive but gives you 10 more years, are you really saving money in the long run? Same thing with coatings, right?
Yeah, and a lot of it is payback. You have to think about payback period for these owners. So if you could design a system, a Cadillac system for them, they have to see and value the payback period. If they know they're going to spend $3 million up front for this insulation system, to know that in 3 years they'll have that insulation system paid off. Because of production rates and how much they can produce, how much money they can make, their ROI, it's having them understand their payback period too. Because you do have some owners that are like, no, we just put the cheapest on. That's your time and material, your lump sum or your lowest cost bid acceptable, things along those lines. So making sure that they understand what they're getting, the owner understands what they're getting, and maybe that might persuade them to go a different route. So,
and from a coatings manufacturer side, that's the end of the side of the conversation that we don't often get brought in for. Is just tell me what coating can go under insulation at these. And we're like, well, but what kind of insulation? What's it going to see? They're like, I don't know. Somebody else is doing that part of it, and so it truly is. Sometimes the low dollar is the one that gets it. But in a lot of cases, you can look at it and say, no, here would be a return that this one is going to last you much longer. And it gets down to the cost of a system and what your return rate is on it. Yeah. It really is an important factor. And then, like Michael had said, you want to look for something that's compatible with everything that you're doing. And that is one of the benefits. A lot of the Novolacs and the phenolics are compatible with both stainless and carbon steel. But some of the things that you need to look at, chlorides are a problem.
Oh, yeah.
And there's a lot of chlorides that are frequently brought in with insulations. And not to mention the environmental chlorides you get with it, but there might be chlorides already embedded in the insulation itself. So all of those are things we know, history has shown us they have a pretty detrimental effect under high temperatures on stainless steel.
Yeah.
They don't like that surface. So we want to make sure that knowing what it's going on, that we're putting coating systems on that will help protect, so that even if you do get a contaminant introduced, we can still say, well, at least there's a barrier there that's going to give us some time. We're looking to protect assets. We're looking to protect, people, personnel, so all of those, nobody wants to see it spring a leak. Doesn't matter if it's in the middle of nowhere or people are around it.
Oh, and we talk about design, we talk about longevity, things along those lines, but we can only do so much to where we also have to rely on the owner to understand that they have to have a maintenance plan in place. They have to have money or dollars set aside to, go look at these systems, make sure they're still working to the way they were designed to work. And before my time with S&B, I've been out to plants where they hadn't done any maintenance in 5 or 10 years because they kept pushing the budget because they just didn't have the budget for that year. You've got to find money in the budget for maintenance. You've got to find money to go check and make sure that you don't have, a pipe getting thin walled or getting a hole in it from corroding out. And,
it really is a full circle kind of thing. I know Jack and I we're in the middle of a long week of interviews, and the amount of times that we've circled around inspection and integrity surveys. And, we recently talked with a company that does some pretty unique new technology for non-intrusive pipeline inspection processes.
Yeah.
Another just asset integrity surveys are important. Yeah. And it helps all of us. It helps to be more environmentally friendly and safer in our workplaces.
Oh, I forget who said this to me, but they made a comment to me a while back. They said, paint, insulation, fireproofing, it isn't sexy, but it's got to be done.
Yeah.
And it's got to be done correctly.
Right.
So.
Right.
Right. Because as we've said probably before on the show, corrosion is one of the most expensive things that faces us as a society. Billions of dollars, probably trillions of dollars at this point, are spent globally every year in an attempt to understand, prevent, and correct corrosion problems.
Right. Right.
So I got an interesting fact for you. So according to the World Corrosion Organization, corrosion costs the global economy around $2.2 trillion each year. Of that, it is estimated that 40 to 60% of pipe maintenance costs are due to corrosion under insulation.
Wow.
40 to 60%.
That's a lot. So this is a big problem. Now, before we wrap up, I do have one more little technical question for you as a specifier. Pipelines, a lot of the times, might not be insulated the whole time, or any equipment might not be insulated across the entire surface. But a lot of times when you coat it, you're probably going to use the same coating. How do you handle the coating specification when the asset is going to be partially insulated?
Well, so you have to know where the breaks are, and you have to have the correct coating system coming out of that pipe that's going to be able to continue to protect the pipe. So you have to look at, if it's going to be out in the sun, if it's going to have any type of environmental effects, you're going to want to put a top coat on top of those Novalax, those phenolics, whether it's a urethane, if it's not high temp, or a silicone, if you're looking at high temp applications. But you have to protect the coating that's coming out from that pipe, from the insulation. And the breaks, where that break is happening, have to be done correctly. You can't just stop the insulation. You've got to vapor stop it. For cold stuff, you got to vapor stop it, seal it up. And for hot, you still have to seal it up. You have to break it and stop it so no water intrusion can just roll down that pipe, because then that defeats the purpose.
Right.
Yeah.
So you have to stop the insulation properly. And that, that having a good contractor is a must on these jobs, that there are going to be a lot of breaks with coatings coming out. So just having a proper contractor out there that's competent, that knows that these are happening, and then understanding from an engineering standpoint, understanding the processes, the temperatures, what's happening, the environment it's going into is huge. So
I think that about does it for corrosion under insulation. As you guys can tell, Michael's an expert in this field. If you guys want to get a hold of Michael, you can go ahead and reach out to Paul at technicalservice@carboline.com.
Yep.
He knows how to get a hold of Michael. Obviously, we're all pretty good friends. So we would like you guys to have an opportunity to know Michael as well as we know him. So we're going to do the 4-question segment that we do with every guest. So the first question that I have for you, Michael, is what's your favorite movie or TV show?
Oh, man. Favorite movie or TV show? Well, my favorite movie of all time is Shawshank Redemption. Anytime it comes on TBS, I'm glued to the TV for 3 hours.
You don't do much in your daily life, do you? I swear that thing plays every day.
If I just come across it and nobody's at home, it's on the background. And and the other thing, I always keep The Office on in background. So if I'm working from the house, The Office is on in my background. Who doesn't like a little bit of Michael Scott in their life?
Right. Right. All right. So I'm going to throw a softball.
Okay.
What's your favorite sport, your team? What do you like to watch, participate in, do?
So it's funny you ask that. I grew up playing sports. I grew up, played through college, and out of everything, soccer is my most favorite.
Wow, it's not football? It is football.
Well, it is, but it is football.
Yeah, technically.
But soccer is my all-time favorite. I can play it, or I can sit and watch it and enjoy it, because I played it for so long that I understand a 1-1 game or a 0-0 game. That's some great defense. Mm-hmm. They had great defense there.
My apologies to all the people in all the other countries who are offended by the word soccer. Anyway.
So I guess that just means we're going to have to put soccer higher on our schedule for our next.
I like going to soccer.
Yeah.
Hey, the World Cup's coming to Houston in a couple of years.
Yeah.
You guys are going to have to just come down.
Yeah.
We are going to have to come down.
Yeah.
The next question on our list is, what's your hobby?
Oh, you're allowed to have hobbies?
Sometimes.
It doesn't mean you get to actually participate in them, but you have something that you would like to do if you had time.
So I'm a huge fisher and duck hunter. Any chance I can get, I'm down in the Delta. I'm down in Louisiana, down off the bayou. I'm duck hunting or red trout fishing.
So the last question: if you were a baseball player, WWE, you had a walk-up song, what would that walk-up song be if you were headed to the ring?
Man, so I'm a secret rap junkie. I'm an 80s baby, but grew up in the 90s and early 2000s. So I call it older school rap.
Yeah, it is.
But
It is.
Some people say it's not, but the Dr. Dre's, the Tupac's, the Eminem's. Eminem's one of my favorite rappers. Some people will say he's not a rapper, but I think he's a mastermind. But Till I Collapse would be my walk-up song. My wife tells me I'm a workaholic. And there's probably a few people that would be listening to this right now that say I volunteer and do a lot. And so
you don't know how to say no.
Don't know how to say no, and I will continue going till I collapse one day. But
There you go.
I think that'd be my walk-up song.
Excellent.
Thank you, Michael, so much for coming on the show.
Paul, Jack, thank you for having me. It's
thanks for
so
coming.
much fun doing this today
It
with
is.
you guys.
It is. So up next is our Tech Tips segment.
You have questions, they have answers. This is Tech Tips.
This is Justin Manuel, Director of the Global Product Line for Carboline. It's easy to remember that CY stands for corrosion under thermal insulation, but it's also important to know that the same aggressive environment can be found under fireproofing materials as well. AMP, formerly NACE, Standard Practice 0198-2017, outlines a detailed approach for the control of corrosion under thermal insulation and fireproofing materials.
Thanks again for listening this week. We'll see you guys in another month.